Yeah. Hi all. Good evening and welcome back to the 12th and the last week of TA live sessions for AI KRR. So before we begin, can anyone just confirm if my audio is clear and if my screen is visible?
Yes, sir, it's clear, sir.
Okay. Thanks for confirming. So yeah, let's get started for today's session. So today we'll be discussing some questions from the last week of the course. And like the previous few weeks, this will also be relatively easier and yeah, so without any further ado, let's get started. So before we start, I just like to mention a note on models that we'll be using in some of the questions that we'll be discussing in the live session. So I'll just go over this once. Um, I'll let you read through it, but I'll give you a gist of it. So basically, what we want to convey here is that if suppose we have a knowledge base that has some contents like man Socrates, which means that Socrates is a man, and then there is a rule that says that for all x, if x is a man, this implies that x is also mortal, right? Then by default, the theory will also include the fact mortal Socrates, right? Because we derive that using this particular rule that was present in the knowledge base. Now, keeping that in mind, another thing that we will need is interpretation of a theory. You can think of it in terms of a mapping, like a relation or a function in mathematics, right? From a domain to a particular range, and an interpretation is basically a model of the knowledge base if all the sentences in the theory are true in that particular interpretation, right? So yeah, you can read through this particular example, but what it tries to convey is that if um, eye of man, right, which is image of man, is a set of humans, and eye of mortal is a set of tall things, because in predicate logic we can, or in a in this particular logic, a predicate can mean whatever we intend it to, right? It's not necessary that if something is called mortal, it will necessarily mean mortal. um, and then the domain in which Socrates is human, Socrates is tall, and the set of humans is a subset of all tall things is a model. We can also say that Plato is a human in addition to Socrates, even though Plato does not find mention in the knowledge base, right? And another concept that we'll be using is basically a minimal model. So a minimal model, as the name suggests, is the minimum, right? Is the smallest interpretation in terms of the number of facts that are present in the model. Okay, so I'll just leave this on here for a couple of seconds and then we'll move on to the questions. There may be one or two questions for which will require this particular piece of information, so I just included it. But any other information that we'll be needing is already present or discussed in the lecture slides. Okay, maybe let's start with the questions then. So this is the first question in front of you. This question tells us identify which of the following are definitely universally true statements. You are given 5 options, and out of these 5 statements, you have to select which of them are definitely universally true. So you can think over it and feel free to share your answers in the chat box, or feel free to unmute yourself and share your answers. A and B, right? So there's a vote for options A and B. And as it turns out, they are in fact the two correct options. So men are mortal, which is a true fact, right? Definitely universally true. And then birds are two legged, egg laying creatures that have beaks. This is also definitely universally true. Um, and then the other 3 options, birds fly, is not necessarily true. because we know that there exist birds that do not fly, and then the other two statements are also not definitely universally true. And yeah, so the correct statements are A and B. Okay, I hope there are no doubts in this question. Shall we move on to the next question then? Okay, so this is in the second question in front of you. So here we are dealing with the generalized closed world assumption that you might have come across in the lecture slides, right? So this tells us that there are three predicates, P, Q, and R, which are atomic predicates, and we are given a knowledge base that consists of three facts. First of which is P or Q or R, right? Second fact is Q, and then the third fact is not Q or R. Okay, now we have to decide which of the following are entailed by the knowledge base under the GCWA, or the generalized closed world assumption. So I'll let you think over it for a couple of minutes and then we can discuss the solution. But in the meantime, you please feel free to share your answers. Okay, so we have a vote for A, D, and H, options A, D, and H. Let's have a look at the solution. Before that, let's have a look at the closed world and the generalized closed world assumption just as a refresher. So you can go through this lecture slides in detail later on, but I'll just give you a brief like key points that we'll need to answer this question. So closed world assumption says that knowledge base plus, which is knowledge base, the addendum of the knowledge base, is the knowledge base and the union of the new facts, which is not of P. We add not of P to the knowledge base if P is atomic and the knowledge base does not entail P, right? This is the closed world assumption. But what is the generalized closed world assumption? This is that we add not of P to the knowledge base for all collection of the atoms Q1 up to Qn if the knowledge base entails P or Q1 or up to Qn, right? So if you have something like Q1 or Q2 or Q3 up to Qn, and P or Q1 or Q2 up to Qn, then we can easily add not of P to the knowledge base. It will become clearer as we discuss the example over here. So let's move over to the whiteboard for that. So the facts that are given to us are P or Q or R, Q, and not Q or R. So this not Q or R we know that this is true, and we also know that Q is true, right? Now for both of these to be true, we know that if Q is true, then not of Q will be false, right? And in order for this whole thing to be true, R has to be true, right? Only then can not of Q or R be true. So using this, we can conclude that R will also be added to the knowledge base. That is what we are doing in this step 4 over here. And once we have done that, we'll see that there are no more useful derivations, so we'll stop there, right? So now our knowledge base is P or Q or R, Q, not Q or R, and R. Now let observe that we also have something like P or Q or R in the knowledge base, that is told that, and we are told that this is true. We are also told that Q is true, right? We are given over here in statement 2. We are also told that R is true. We just derived that. So Q or R will also be true, right? So now this particular thing fits the construction or the syntax of a generalized closed world assumption. And because these are already true, we can add not of P to the knowledge base as well by the generalized closed world assumption. So we add not of P to the knowledge base as well. And if we match this to the options given to us, we will find out that the correct options are not of P, Q, and R. Okay. So any doubts there?
For a minute, I was out. How did not be? How can that be added, sir?
Yeah, so for adding not P, we have to use the generalized closed world assumption, which I was just explaining. So if I go back to the construction or the way the generalized closed world assumption is stated, right? If we have something like P or Q or P or Q1 or Q2 up to Qn, and the knowledge base entails Q1 or Q2 or up to Qn, then we can add not of P to the knowledge base as well using the generalized closed world assumption. What this means in practice is that, so I hope it was clear how we were able to add R to the knowledge base, right? Is that much clear, or should we go over that again? Again, okay, so let's go over the solution once more. So basically, let me erase all this so that it's easier for everyone to understand. Okay, so basically what is happening is that we are already told that these three facts are present in the knowledge base, right? So we can safely assume that all of these three are true, right? Which means Q is true, not Q or R is true, and P or Q or R is true, right? So this thing is true, and Q is also true. Now if we place this true over here, what will be not of Q if Q is true? It will be false, right? Not of true or R, this will be false or R, right? Now we know that this statement is true. In order for an or statement to be true, one of the facts or both of the facts have to be true, right? But we already know that the first part is false. So the second part has to have a truth value of true so that the whole statement becomes true. From that we conclude that R is also true, right? And then we add R to the knowledge base. Now we see that this P or Q or R, this kind of follows the format of the generalized closed world assumption given to us, right? We know that this is true, and we also know that Q or R is true because both Q and R are true independently, right? Because we know this fact and these three are connected by or operators, because of the fact that Q or R both are true, this whole statement will turn out to be true in any case. So the value of p kind of does not hold any relevance over here. So even if we had a not p in the knowledge base, this whole statement would still be true. That's why we can safely add not p to the knowledge base by the generalized closed world assumption, and that is what we did, and that is how not p became a correct option. So does that help somewhat? Okay, that's great. Thanks for the confirmation. So I hope that was clear. If there are any remaining doubts, please let me know. We can come back to this question again. For now, let's move on to the third question then. This is what will deal with the minimal model that I was mentioning a while ago, right? So we are given a knowledge base, right? This knowledge base is over here at the bottom, right? And we have to identify the set of statements that define a minimal model for circumscription on the given knowledge base, right? So we are also told that Kia is a kiwi, Chile is a penguin, and Tweety is a canary. So all these are three different birds, and the knowledge base has these particular facts. The first is that for all x, if x is a bird and x is not abnormal, using these two we can imply that x flies. Okay, this is the first fact in the statement in the knowledge base. The second statement is that for all x, if x is a kiwi or x is a penguin, then this implies that x does not fly, right? And we're also given that Chili is a bird, Tweety is a bird, and Kia is a bird, and all three of these are different entities. None of these three are overlapping with each other, and we are told that Chili is a penguin and Kia is a kiwi. This is the knowledge base given to us. Now we have to identify which of these statements will define a minimal model for circumscription. Okay, so I'll let you think over it for a couple of minutes and then we can discuss the solution. Okay, so we have a vote for some options, but I'll give you one hint. There's only one correct option. Okay, and focus on the word minimal model. Also another hint, AB over here basically stands for the set of abnormal entities, right? So in this particular case, abnormal refers to a bird that is not able to fly, right? So that's also a hint. Okay, let's discuss the solution and let's see what answer we get. So this is the knowledge base given to us, right? And let's use forward chaining to derive some new facts that we can add to the knowledge base, right? Now we are told that chili is a penguin, right? And Kia is a kiwi. Now using this particular fact, this tells us that for any x, if x is a kiwi or x is a penguin, this implies that x does not fly. Because chili is a penguin, we can conclude that chili does not fly. That is fact 1. By similar logic, we can conclude that because Kia is a kiwi, Kia does not fly. Right? Do you agree with me? Okay, that's great. Now that we know that both Kia and chili do not fly, let's look at the first fact or first statement given in the knowledge base. This tells us that if x is a bird and if x is not abnormal, only then we can conclude that x flies. Now we know that both Kia and chili are birds, so this part is ticked off, but uh, this portion must have been unsatisfied. That's why we could say that both Kia and chili could not fly, right? So this basically concludes that Kia and chili both are Kia and chili both are abnormal. Do you agree with me? Okay, great then. So now we know we have some information about these two birds, Kia and chili, but we still do not have enough information to conclude something about Tweety, right? So we formulate these two rules, which basically tells us that if Tweety is not abnormal, then we'll conclude that Tweety can fly. If Tweety does not fly, then we conclude that Tweety is abnormal. It's just a roundabout way of writing the same thing, but basically what we conclude from here is that we can for sure say that these two are abnormal birds, Kia and chili, but we cannot say that for sure Tweety is also abnormal, right? Now coming back to the solutions, so the set of abnormal will definitely contain Kia and chili, right? That removes options A, B, C, D by default, right? Because A, B, C, D do not contain both Kia and chili together in the set of abnormal entities. Now whether or not Tweety will be included in the abnormal set or the not abnormal set, that is a question that we are yet to answer. So both options E and H could be correct. Both of these are models, okay? But we have to select a minimal model, right? With the least number of true facts that we know that we can entail. That is option E. Here we can for sure say that Kia and chili are abnormal, but we cannot say for certain that Tweety is abnormal. So we would not put Tweety in the set of abnormal candidates, and that's why this is a minimal model. So the correct option is option E. Okay. Shall we move on to the next question then? Okay, great. So question 4 is also based on the same knowledge base given to us, but here we have to select the set of models, not the minimal model. So which option do you think would be correct, or options will be correct? Remember, here we have to select the correct models, not necessarily the minimal model. So based on the discussion that we just had, which one do you think would fall in the category of not flies, and which one would fall in the category of flies? So one hint here is that here the abnormal set is replaced by the not flies set, right? Not flies is equivalent to abnormal, right? So we know that Kia and Chili for sure are abnormal, so they do not fly. But we don't know whether Tweety is abnormal or not, so we cannot say whether Tweety can fly or not, right? So both options E as well as H could be correct models, right? And because we are not told to select the minimal model, we'll tick off both options E and H. Okay, because we know for sure that Kia and Chili do not fly. Whether we should include Tweety in the set of not flies or flies is our question, and for addressing or for including both of those possibilities, we'll say that both options E and H are correct. The other options are not correct because they either do not include both Kia and Chili in the set of not flies, or they wrongly include Tweety in only one set and include Chili in the flies set, right? So E and H are the correct options. Shall we move on to the next question then? Any doubts here? Okay, thanks for confirming. So coming to question 5. Now this is kind of a recall based question, okay? So this question asks us which of the following statements are true with respect to default logic and circumscription. So yeah, I'll just give you a couple of seconds to think about it. Which of these do you think are true in the context of default logic and circumscription? We saw some examples of default logic in the previous few questions and circumscription in the previous few questions. B. So we have one vote for option B, and it is actually correct, right? In default logic, we do provide a mechanism for specifying explicitly which statement should be added to the knowledge base when it is consistent to do so. And we did actually do that something like that in this particular question, right? In this generalized closed world assumption question, right? We added not p to the knowledge base because it was consistent to do that. And then questions 3 and 4 dealt with circumscription. So here, if you would have noted, here when we were finding the minimal model, we minimized the set of abnormal candidates only, right? So does that give you a hint about what do we do in circumscription? We minimize only the abnormal predicates, right? When we are finding the minimal model, we find it with respect to the abnormal predicates only. So the correct options here would be options B and C. Okay, this is a straightforward recall based questions. If you have gone through the lecture videos or the lecture slides, they should be straightforward. Okay, I'll assume there are no doubts there, but if there are, please let me know. Let's move on to the 6th question then. So now we are done with default logic. We are now moving into the domain of discrete event calculus. Okay, and here we are told that given that initiates a comma f comma t is true, when does a fluent f hold at time t1? Okay, So just as a refresher for what does this mean, let's just go over the lecture slides. Right. So initiates E comma F comma T basically tells us that an event E over here occurs at time T and results in the fluent F becoming true after T. Okay. So if you're following like a linear timeline, okay, and if the event E occurs at the time step T, then after T, which is from T plus 1 onwards, fluent F will become true. Okay. For example, if there is this person called Kumbhkaran 1, okay, if the event wake up Kumbhkaran 1 happens at time T3, that is Kumbhkaran wakes up at time T3, then from T4 onwards, this event, this fluent awake Kumbhkaran 1 will be holding true. Okay, and because this is a discrete event calculus, there is nothing in between T3 and T4, right? There's no gap between T and T plus 1. So that is a given statement. So with this in mind, which of these options do you think would be true? You may also need to know what exactly is meant by clipping. So let me show that as well. Right. So by clipped, T1F T2 means that a fluent F that was true is made false sometime after or at time point T1 and before T2. Right. So if we have something like a timeline over here, right, this is our timeline, this is T1 and let's say this is T2. If the fluent F was made false for the time period between T1 and T2, or let's say T3, okay, then we will say that F was clipped between T1 and T3, right? This is the definition of clipped. Now coming back to the question that we had, now with these two definitions in mind, which of these options do you think will be correct? I'll give you a couple of minutes to think over it and then we can have a look at the solution. Okay, so we have a vote for options B and D and E. Let's have a look at the solutions one by one and see which of them are correct. Okay, so the first option says that given that initiates A of T is true, fluent F holds at time T1 when action A happens at time T1. Now this is not right because just like we saw, if an event occurs at time T1, then the fluent F will hold true from T1 plus 1, right? So in order for a fluent F to hold true at time T1, the event must have happened at time T1 minus 1, right? Only then can the fluent F be true at timestamp T1 minus 1 plus 1, which is T1, right? So action A must have happened at time T1 minus 1. That is what is given in option B, and that's why option B is correct, right? Options A and C are not correct by default, right? Because just like because of the reason we discussed just now. Option A is incorrect. Option C is incorrect because we don't know what happened in the time period between T1 minus 5 and T1, right? So a lot of things could have happened and we're not given enough information, so we can't say that action A happens at time T1 minus 5. Now, if we are given the additional information that action A happened at time T1 minus 5, and so at T1 minus 4, fluent F became true, right? And if no clipping of the fluent F happened between T1 minus 5 and T1, this would mean that the fluent F would continue to remain true at T1 minus 4, T1 minus 3, T1 minus 2, T1 minus 1 and T1. Okay, so that's why option D is correct, right? And option E is also incorrect because of similar logic. Because option E is incorrect, option F would be correct. So the correct options are B, D and F. Any doubts there?
Sir, not understood.
Okay, let me try to explain with the help of the whiteboard. So there are few things that we need to understand. Okay, this is clipping. Okay, if between timestamps T1 and T3 a fluent F is made to be, or a fluent or an event, whatever it is, if it is given the truth value false forcefully between this time period T1 to T3, then we say that that fluent was clipped between time periods T1 and T3, right? Now initiates this tells us that if an action, if an event A, let me actually write it above. Let's say this is timestamp T1 and action A happens at timestamp T1. Then from timestamp T1 plus 1, fluent F will be holding true. And we write it like this. Okay, so this will actually be T and T plus 1. Okay, so if action A or an event A happened at timestamp T, then from T plus 1 onwards, F would be having the truth value true, right? And because this is like a discrete event calculus, there is nothing in between T and T plus 1, right? Like in discrete numbers, there is 1, 2, 3. There's nothing in between 1 and 2, right? And 2 and 3. Similarly here, there's nothing in between T and T plus 1. Now with these two in mind, and we are also given that initiates AFT is true, when will fluent F hold at time T1? So this is the point over which we have to revolve our answer. Like fluent F has to hold at time T1 or has to have a truth value true at time T1. So let's mark that. This is our timeline. At timestamp T1, fluent F is supposed to be true, right? Now in order for this to be true, and given that initiates AFT was true, action A must have happened at, or event A must have happened at timestamp T1 minus 1, right? Because event A happened at T1 minus 1, then by this logic of initiates that we just saw, at timestamp T1 minus 1 plus 1, right, which is equal to at timestamp T1 fluent F will be holding true, which is what we want. This is one scenario. Okay, so because of this option B is true, right? Now, what if the action or event A happened at timestamp t1 minus 5? So let's draw that scenario. Let's say this is t1 minus 5, this is t1 minus 4, this is t1 minus, this looks like 3, and finally t1. Now what we want is that fluent f must be holding true at timestamp t1. So at this point fluent f must have a truth value true. What if event A happened at timestamp t1 minus 5? Then fluent f would hold true at timestamp t1 minus 5 plus 1, which is t1 minus 4. Right? Do you agree with me till this point? Okay, I'll take that as a yes. Yeah. So now the question remains, now that we know that at timestamp t1 minus 4 fluent f was true, we have to deduce whether f remained true in between this period, right? But we are not given enough information about this period t1 minus 5, t1 minus 4, t1 minus 3, t1 minus 2, t1 minus 1, right? What if fluent f became false sometime over here? In order to avoid that, if we can somehow say that event f was not clipped between this timestamp, this time period, which means that it did not take the value false between this period, we will know that the truth value of true that the fluent f was assigned here will continue to be true at t1 minus 3, at t1 minus 2, at t1 minus 1, and at timestamp t1. That is what is covered by option D over here, right? If action A happens at time t1 minus 5 and f is not clipped between t1 minus 5 and t1, then f will hold true at timestamp t1. And by similar logic, if f was true from the beginning itself, f will continue to remain true if f was not made false in between t0 and t1, or in other words, if f was not clipped between t0 and t1. So does that clarify some of the doubts?
Sir,
Okay, that's great then. So let's move on to the next question then.
sir, here one doubt. What is the truth value at t1 minus 5?
Truth value of what?
Some action. So we have to say true or something.
Yeah, true or false?
No, we said t1 minus 4 is truth value 2. True we are talking. So what about truth value at t1 minus 5? When the action initiated.
Yeah, so
The
when
instant the action initiated.
yeah, so here at t1 minus 5 we are not told whether f is true or not true, right? So there can be two cases, either f was true at t1 minus 5 or
Okay.
f was false at t1 minus 5. If f was true at t1 minus 5, it will continue to be true at t1 minus 4 because of this initiates action that we just did. If if f was false at t1 minus 5, it will become true at t1 minus 4 because of the initiates action that we just did.
Sir, okay, sir, thank you.
Okay. Okay, then moving on to question 7. So here you are given a story in the form of a set of statements in the English language. Okay, and we are still working in the domain of discrete event calculus. Now what you have to do is you have to read through this particular given statements, and we have to decide which of the following from the options are true sentences in the domain theory, the narrative, and the inferences. Okay, And as per notations, all capital letters are universally quantified variables, and you have to decide which of these are correct options. So I'll let you read through the statements and try to work through the solution for a couple of minutes, and then we can have a discussion. Okay, so we have a vote for options B, G, I, and K. So these all are correct, but I'll give a hint. There are more correct options. Okay, I'll actually give you the answer because I think that will be easier um, for you to map the statements to the options, right? So the uh, interesting thing is that all options here are actually correct. Now, what I'd like you to do is try to map these options to the story given over here and verify for yourself if all of these are in fact true or not. Okay, so let's go through all the options. So what the first? So let's go to the story first. Okay, the story tells us that Putin's Russia invaded Ukraine, a peaceful country. Invasion implies end of peace and beginning of war. The Russian forces bombed a maternity hospital. The hospital got destroyed as a result. It is a war crime to bomb civilian buildings. Right? This is the statement of the story given to us. Oh, by the way, just a clarification. This is just a story. Okay, don't take any fact that is mentioned over here as a you know universally true statement. Okay, um, just to avoid any controversies. Okay. So yeah, so let's go through the options one by one. Um, so option A tells us that happens invasion of Ukraine by Russia at timestamp T1. Okay, so at timestamp T1 our story begins. Okay, so once this happens, this maps to the first line of the story, which is given by Putin's Russia invaded Ukraine, a peaceful country, right? So this peaceful country maps to this particular fact. Initially Ukraine was at peace. Okay, invasion implies end of peace, right? Now this basically maps to this particular part. um, not holds at peace Ukraine, right? Once the war started, the peace was destroyed, right? um, Beginning of the war, so at war Russia and Ukraine at timestamp T3, and obviously by common reasoning T2 is greater than T1 and T3 is greater than T2, right? um, Option F states that once invasion of X and Y started, X and Y are at war at a given timestamp t. So this is actually a generic rule. This is not a particular statement with respect to the story that is given over here, right? And if the invasion of X and Y terminates, then Y returns to peace. That is a truth that also happens at timestamp t, right? And then initiates bombed X comma Y. Y becomes destroyed at timestamp t, right? This basically maps to the this will map to the this bombing of the maternity hospital over there, right? And that is kind of summed up in the last option K over here, which says that if the bombing of Y by X happened at timestamp t, then and initiation of the bombing on Y by X and the destruction of Y happened at timestamp t, which means that Y was destroyed. This becomes true at timestamp t, right? That is what is being conveyed by all the options here. So it may not be that all of these sentences in the story map to any specific option, but some of these are generalized options as well. But the truth is that all of these actually hold true in the context of the story and the discrete event calculus domain. Okay, that's why we are asked that we have to select the true statements in the domain theory, the narrative, and the inferences, right? Okay, does that clarify the question? Okay, I'll take that as a yes. Let's move on to the next question then. So this is again a recall based question, right? It asks us what is the frame problem in the context of event calculus. So which option do you think would be correct? Only one option is correct here. A, that's right. So we have a vote for option A, and that is in fact correct, right? The frame problem is basically the problem of deciding which fluents remain or become true at future time instances, right? The reason B is not true here is because we don't study the effects of stochastic actions, right? So stochastic basically refers to something that has randomness in it, right? Stochasticity means randomness. Because we are not dealing with any kind of randomness over here, option B is not relevant to event calculus, right? And by similar logic, option C is also not relevant. The correct option is option A. Okay. Okay, this was a straightforward recall based question. Moving on to question 9. So now we have gone into, I think, epistemic logic, if I'm not mistaken. So this question tells us that let P stand for the statement Putin is going to attack Ukraine. Okay, what does the statement K Putin, not of K Biden, not of P represent? Let me just show you an example. Yeah. So in this example of a tiny pack of cards that you may have come across in the lecture slides, this basically K of something basically means that whether that A knows something or not, right? So KA2B basically means that A represents Anne. So Anne knows that Bob, which is represented by B, holds 2. which is 2 is reference to the set of cards, 3 cards named 1, 2, and 3, right? So KA to B basically means that Anne knows that Bob holds card 2, right? KA not of 2B means that Anne knows that Bob does not hold card true, right? So on and so forth. Now this is an example. Coming back to the question, what do you think is represented by this fact? Okay, so we have a vote for option B. So this is a common pitfall that many of us actually run into. So although it seems like B is the correct option, but if we take a closer look, we'll observe something different, right? So what exactly happens here is, so the first part for sure indicates that K of Putin indicates that Putin knows something, right? So Putin knows. So the correct options would be either A, B, or D. Putin does not know. This itself is eliminated, right? Now Putin knows that Biden does not know not of P, right? Where P represents Putin is going to attack Ukraine. Now this tells us that Putin knows that Biden does not know whether P will happen, right? So we cannot say for sure that Putin knows that Biden does not know P. Biden may or may not know P, right? Because the only thing that is given to us is Biden does not know not of P, right? So the correct option would be option D. In fact, Putin knows that Biden considers it possible that P. Okay. Yeah, so I think one of you did vote for option D. That is in fact correct. Okay. Okay. Let's move on to the next question then, which is question 10. Okay. So this is related to the muddy children problem. So first of all, are all of you familiar with the muddy children problem?
No, sir.
Okay. So let me just give the context over there. Okay. Okay. So the muddy children problem is basically, so there are n children. Okay. Let's say C1, C2, C3, and C4. Okay. And these 4 children are playing in a ground where there is mud. Okay. And their parents have told them that if they get mud on their foreheads, they will get a scolding. Now, but these children also are children, so they would want to play and get dirty, right? So some of these get mud on their foreheads. Let's say k of them. So there are n children. N here is equal to 4. Let's say one of them gets mud on their forehead, which is represented by this number k. Okay. Let's say C1 gets mud on their forehead. So in order to know whether they have mud on their forehead or not, what their parents will do is that they will ask the children. They will basically tell the children that at least one of you has mud on your forehead. They will not specify who has. Okay. And then they will ask each of the children whether you have mud on your forehead or not, and the children can answer only in yes or no. And we also assume that the children are intelligent enough to give logically sound answers. Okay. So is the setting clear before we move on to the details of the problem? Okay.
Yes, sir.
Okay. So when there is only one child with mud on their forehead, so when the father asks who has mud on, do you have mud on your forehead or not? Okay. and the children also are aware of the fact that at least one of them have mud on their forehead, right? Now C2, C3 and C4, they will see that C1 has mud on their forehead, right? Let's say they also know that only one of them has mud on their forehead, right? This is a trivial case. Because C1 sees that C2, C3, C4 don't have mud on their forehead, C1 might be the only person who has mud on their forehead. So C1 will say yes, others will say no, no, no. Okay, so this concludes the muddy children problem. What if what if K is true? That is, two children have mud on their forehead. Let's say C1 and C3 have mud on their forehead. Okay. Now in the first round, when the parent asks them, do you have mud on your forehead or not? So at this point, the children don't know that exactly two of them have mud on their forehead. They just know that at least one of them have mud on their forehead, which means that either one or more of them have mud on their forehead. Okay, so in the first round, when the parent asks, do you have mud on your forehead or not, C1 will see that C2 does not have mud on his forehead or her forehead. C3 has mud on his or her forehead, and C4 does not. Okay, but because there were at least or greater than one number of children who had mud on their forehead, C1 will say no, because C1 does not know whether he or she himself has mud on their forehead or not, right? And one other assumption is that a child will answer yes only if they are exactly sure that they have mud on their forehead. Okay, so in the first round, C1 will say no, I don't have mud on my forehead, because C1 does not have enough evidence to say whether C3 is the only person with mud on their forehead or not, right? Or whether he or she himself has mud on his forehead or not. C2 and C4 will clearly see that C1 and C3 have mud on their forehead, so they will say that they don't have mud on their forehead. And by similar logic, C3 will also say that I don't have mud on my forehead. But this was round 1. In round 2, because C1 heard C3 saying that he or she does not have mud on their forehead, this will give information to C1 that maybe C3 also thinks similarly to me, right? Which means that I also must have mud on my forehead, because C2 and C4 clearly don't. So I must be the only other person with mud on my forehead. So in the second round, C1 will say yes, I have mud on my forehead. C2 will continue to say no. C3 will say yes by the similar logic, and C4 will say no. So by the second round, we will know who exactly has mud on their forehead or not. Or which of the children.
Sir, I just have a question over here.
Yeah.
In round 2, whether C1 gets a clarity that it has mud on its forehead, or it just assumes,
No.
thinking of C2 is not having, so that I do have.
C1
Is
gets
it an assumption or?
in round 2, C1 gets clarity that he or she does have mud on his or her forehead, because he sees that C2 and C4 do not have, and C3 in the previous round said that he did not have, which means that C3 must have seen another person with mud on their forehead, which is definitely not C2 and C4, so it must be C1 only. C1 is the only culprit left. So that confirms his suspicion, and then he says this confidently, he has mud on his forehead.
Yes, I got it. Thank you.
Okay. So if you keep doing that, if you keep increasing the number of children who have mud on their forehead, you will notice a trend, which is the parent needs to ask the question k times in order to arrive at the correct solution of who has mud on their forehead and who doesn't have mud on their forehead. Because for the k-1 attempts in which he or she asks the questions, the children will keep on saying no, 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 right? They must have at least k-1 attempts to have enough information to confidently say whether they have mud on their forehead or not. This is the muddy children problem. Okay. Now coming back to our question. Here we have 4 children: Aman, Bindu, Charu and Deepti. Aman and Deepti have muddy foreheads and the others are not muddy. What is the minimum number of times the father has to repeat the question for the children to state whether they are muddy or not? So here n is 4, k is 2. So how many times does the parent have to ask the question in order to arrive at the final solution?
Two.
2. That's right. For k minus 1 times, which is for 2 minus 1, which is for 1 time, for 1 round, the children will keep saying no, 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 right? And then after k minus 1 rounds, which is after 1 round, all children will have enough information to confidently say their answers. So in the second round, which is k, which is equals to 2, the father will be able to find the correct solution as to who is muddy and who is not. Okay. So that actually brings us to the end of the questions for today. I guess we don't have another week. So yeah, so this brings us to an end of the questions for today and the questions for all the live sessions that we have been having. So unless you have anything specific that you would like to discuss, I would just say that all the best for your exams. I hope this course was of some help and some interest in your life. And yeah, if you have any feedback for the live sessions, please feel free to share it with me over here directly or through email or through the forms that have been circulated by the NPTEL team. And yeah, that's it from my side. Is there anything that you would like to discuss? In the practice session, it suggested that 3 is the answer for question 10. Are you sure that over there were how many number of children who were muddy? Was that 3 or was that true? Or was that 2?
2, sir.
2. In that case, the father must ask the question only 2 times. If the practice session said that is 3, then it's possibly some error, and I would encourage you to bring that to the attention of the NPTEL team.
Sir, in this type of question, it is independent of how many children are there.
Yeah, that's right.
Simply answer is blindly number of muddy children. That's all.
Exactly. So if you want, I would actually also highly encourage you to read the Wikipedia page for the muddy children problem. That has a very nice explanation of the whole proof by induction.
Sir.
Okay, so I would highly encourage that you go through that if you haven't already. To answer
Sir,
one,
and, what if a muddy children are three?
if the muddy children are 3, then probably the parent would have to ask the question 3 times in order for all the children to be able to give confident answers. For the first 2 rounds, they will keep saying no, 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 because they don't have enough information. But for the third round, they will be saying whichever of them will be having mud on their forehead will be saying yes.
Sir, and can we get the hard copy of this questions, practice questions?
These are already shared with you. So the Google sheet in which you have the links to each session's recorded videos, you also have a link to a drive folder where all these questions are already uploaded.
Okay.
Okay.
Thank you for the
And
guidance.
yeah, no worries. Also,
Sir,
yeah,
sir.
just 1 minute, Khalid. So there are also in that same folder that I was just mentioning, you will also find some additional questions that usually happens in an extra live session that may or may not happen in some semesters. This semester, unfortunately, it wasn't possible for me to take another extra live session, but slides are uploaded in the drive folder, so I would encourage you go through that, and maybe those questions will also help you. Yeah, please go ahead.
Sir, how to get the drive? The way we are getting the material, same drive.
Let me just show it to you. So this is the Swayam portal, right?
Sir.
This is the problem solving session. You have to click here,
Sir.
that will lead you to this sheet, and this presentation folder link, this will lead to a drive folder, and this is where you will find all the slides from all the weeks.
Sir, okay.
Okay.
Sir,
To
today I joined late. Can you just go to the question number 2? Little confusion.
Sure, I'll just reply to one question in the chat box. Kanaya, I am not sure about the admit card procedure. Unfortunately, I don't deal with that aspect of the course, so I would encourage you ask the NPTEL team about that. Okay, coming to question 2 as requested. Yeah, so here basically we are told to use a generalized closed world assumption. We are given three statements, P or Q or R to be true. Q is true and not Q or R is true. Okay. Now, by reasoning, because we know that not Q or R is true and Q is true, we can say that R is true, right? Because if Q is true, not of Q will be false, and for not of Q or R to be true, R must be true, right? So we add R to the knowledge base. Now we have Q to be true, R to be true. So Q or R together will be true as well. That plus this first statement given to us, P or Q or R, right? Because you already know that Q or R is true, it becomes immaterial whether P is true or not P is true. So we can add not P to the knowledge base by a generalized closed world assumption. That is what happened in question 2. Okay. And to answer the chat question by Deepa, I honestly don't have any answer to whether you'll get the solutions for the assignment. It doesn't look like you will, because that is the trend that has been continuing since the past few semesters. But if you have any specific doubts, any question from any assignment, you are encouraged to post your partial solutions, and the lead TA, who is Bhaskaran sir, will be responsible for addressing your queries from there on. Okay. Anything else that you would like to discuss before we end the session?
Yeah, sir. Thank you for the session. It was so informative and helpful for us for the further topics.
Thanks for attending, Shankar. Okay, then if nothing else, then maybe
Thank you, sir. Thank you so much, sir.
thanks a lot for attending. So, all the best to all of you.
Thank you, sir.
Thank you so much, sir.
Okay,
Thank you so much.
okay. Thanks a lot to all of you, and yeah, let's meet in possibly another course in another semester in the future. See you all.